In December of 1985, a small group of horses stepped off a transport crate onto frozen, barren ground at the edge of the Gobi Desert, in a stretch of northwestern China so degraded that almost nothing grew there anymore. They weren't ordinary horses. They were the last of an entire species, animals that, just a few years earlier, had been officially declared extinct in the wild everywhere on the planet, surviving only behind fences in a scattering of zoos across Europe and North America. Nobody watching that release knew for certain whether these animals could actually survive out there, in a landscape their own ancestors had once roamed freely, but that had grown considerably harsher in the decades since. 40 years later, more than 900 of their descendants galloped freely across 4 separate Chinese provinces, and what happened to the land itself in the years since their return has become one of the more quietly remarkable case studies in conservation and ecology anywhere in the world. This is the story of Przewalski's horse, the only truly wild horse species left on Earth, and the 4-decade project that brought it back from the edge of complete extinction into some of the most unforgiving desert terrain on the entire planet. To understand why this story matters, and why scientists specifically chose this species and this location for what would become one of the most ambitious species reintroduction efforts ever attempted, you first need to understand exactly what Przewalski's horse actually is, and how genuinely close it came to disappearing from existence entirely. Named after the Russian explorer Nikolai Przewalski, who documented the species for Western science during a 19th century expedition through Central Asia, this stocky, dun-colored horse represents something genuinely unique within the broader animal kingdom. Unlike the modern domestic horse, and unlike the various populations of feral horses found roaming parts of North America and elsewhere, all of which descend from horses that were, at some point in their lineage, domesticated by humans, Przewalski's horse has never been domesticated. It stands as the only surviving truly wild horse species on the planet, a direct, unbroken evolutionary line stretching back tens of thousands of years, distinguished by physical characteristics that set it apart even from other wild-looking horse breeds, including a notably large head, a thick muscular neck, and a distinctive black coloring along the lower portion of its legs. For millennia, these horses roamed freely across the vast steppes and desert regions of Central Asia, including large stretches of what is now northwestern China. But by the middle of the 20th century, a combination of hunting, habitat loss, driven by expanding human settlement and agriculture, in competition with domestic livestock for increasingly scarce grazing land, had driven the species to a genuinely precarious brink. By the 1960s and into the 1970s, wild populations had collapsed entirely. The species survived only because a small number of individuals had previously been captured and transported abroad, preserved in captivity in zoos and breeding facilities scattered across Europe. Essentially, the entire genetic future of an entire species reduced down to a small handful of captive animals, none of them living anywhere near the wild habitat their ancestors had once called home. This is precisely the situation that prompted Chinese conservationists working in the mid-1980s to launch what became known as the Wild Horses Return Home Project, an ambitious, long-term effort specifically designed to bring Przewalski's horse back from this captive-only existence and re-establish genuinely wild, self-sustaining populations within its historic range in northwestern China. The project began in 1985, when the first individuals were brought back from breeding facilities in Germany, the United Kingdom, and the United States, transported to a newly established breeding base in Xinjiang in China's far northwest, specifically chosen because it sat within the species' historic range and offered the kind of steppe and desert habitat these horses had evolved to survive in. It's worth pausing here to explain exactly why this particular reintroduction effort represented such a genuinely difficult undertaking, considerably more complicated than simply transporting some horses to an open field and releasing them. Reintroducing an entire species back into the wild after it has existed only in captivity for decades requires solving a whole series of interconnected biological and logistical challenges, each one carrying real risk of failure if not handled correctly. The first and most fundamental challenge involves genetics. Because the entire global population of Przewalski's horses descended from such a small number of founding individuals originally rescued from the wild before the species' complete extinction there, every single captive-bred horse involved in this reintroduction effort carried an inherently limited, genetically constrained lineage, raising real concerns about inbreeding and reduced genetic diversity, both of which can weaken a population's overall resilience and long-term viability. Addressing this challenge required careful, deliberate breeding management, using DNA testing conducted at the molecular level, drawing on small samples of hair and fecal matter from individual horses, to enable precise, genetically informed breeding pairings specifically designed to maximize genetic diversity within the growing captive population before any animals were ever actually released into the wild. The second major challenge involved behavior rather than genetics. Horses that have spent generations living in captivity, however spacious or well-managed that captivity might be, simply don't know how to survive as truly wild animals. They haven't learned how to locate water sources across an unfamiliar, often harsh landscape. They haven't developed the physical conditioning needed to travel long distances across difficult desert and steppe terrain. They haven't learned to recognize and avoid predators, or how to survive extreme temperature swings, including the brutal winter cold that can drop well below negative 40 degrees in the specific regions of northwestern China, where these reintroductions were planned. To address this, Chinese conservationists developed a careful, staged rewilding process. Rather than releasing captive-bred horses directly into fully open wilderness, individual animals selected for reintroduction first spent extended periods living within large, semi-wild enclosures. Spaces considerably larger and less controlled than a typical zoo enclosure, but still offering some degree of managed support, including supplementary feeding and water access, while the horses gradually relearned, or in the case of younger horses born within these transitional enclosures, learned for the first time exactly the kind of practical survival skills their fully wild ancestors would have known instinctively. This careful, staged approach to reintroduction unfolded gradually over an extended period, rather than as a single dramatic release event. Early efforts focused on establishing a core founding population within these semi-wild breeding and training enclosures, carefully building up both the population's overall numbers and its genetic diversity before actually pushing forward with releases into genuinely open, unmanaged, wild habitat. One particularly well-documented early cohort, referred to by researchers as the Yungar herd, consisted of a small, carefully selected group of mares and stallions specifically chosen for their combination of sufficient genetic diversity and physical strength, representing exactly the kind of foundational breeding group needed to give the broader reintroduction effort its best possible chance of long-term success. Over the decades that followed, this patient, methodical approach gradually expanded. Additional release sites were established beyond the original Xinjiang breeding base, including the Kalamaili Nature Reserve in Xinjiang, the Yangtze Extreme Arid Desert Nature Reserve, and the Dunhuang West Lake Nature Reserve in Gansu Province, along with a population established near Beijing at the Nanhaizi Milu Park. Each of these locations offered its own particular combination of habitat conditions, and by maintaining several geographically distinct populations, rather than concentrating the entire reintroduced population in a single location, conservationists were able to reduce the overall risk that a single localized disaster, whether a disease outbreak, an extreme weather event, or some other unforeseen catastrophe, could threaten the entire reintroduced population all at once. The results of this sustained 4-decade effort have been genuinely remarkable, and they're worth stating plainly because the scale of this recovery represents a considerable achievement within the broader field of wildlife conservation. From that original founding population of just 11 horses brought back to China in the mid-1980s, the total population of Przewalski's horses in China has grown to surpass 900 individuals as of recent counts, representing roughly 1/3 of the entire global population of this species. In Xinjiang specifically, the wild population alone has grown to nearly 400 individuals. As recently as April of 2026, an additional 30 Przewalski's horses were released into the Kalamaili Nature Reserve after completing their staged rewilding training, part of the ongoing, continuing expansion of this reintroduction effort even decades after it first began. These horses now live and roam freely across 4 separate Chinese provinces and autonomous regions: Xinjiang, Gansu, Inner Mongolia, and Ningxia, a considerably wider geographic distribution than existed at any point during the species' initial captive-only survival period. This achievement has drawn genuine international recognition within the broader conservation science community, with the project frequently cited as one of the more successful examples of large mammal species reintroduction conducted anywhere in the world. It's worth understanding why reintroduction efforts like this one carry such particular significance and such particular difficulty within conservation biology more broadly. Bringing a species back from a state of complete extinction in the wild, sometimes referred to as extinct in the wild status, back to a genuinely self-sustaining, free-ranging wild population, represents one of the more difficult outcomes conservation science can attempt to achieve, considerably harder than simply maintaining an already stable wild population through ongoing protective management. Many reintroduction efforts attempted for various species around the world over the past several decades have struggled or ultimately failed, undermined by exactly the kind of genetic, behavioral, and habitat-related challenges described above. The sustained, 40-year success of the Przewalski's horse reintroduction effort in China stands out specifically because it managed to navigate all of these challenges simultaneously, over an extended, multi-decade timeline, while continuing to expand, rather than merely maintaining a fragile, static population. Now, it's worth turning to the specific, land-related dimension of this story. because the environment these horses were reintroduced into carries its own significant separate story worth understanding honestly and carefully. Northwestern China, including large portions of Xinjiang, Gansu, and Inner Mongolia, has faced a genuinely serious, well-documented desertification crisis over recent decades. According to figures describing this broader ecological challenge, more than 350,000 square kilometers of land across this general region has degraded over the past 3 decades, transforming productive grassland and steppe habitat into increasingly barren, cracked terrain. Spreading dunes and dried-up river systems, a combination of factors including overgrazing by domestic livestock, unsustainable agricultural practices, and broader climate pressures affecting this already arid region. China's government has invested enormously in combating this desertification crisis through large-scale tree planting efforts, with reported figures suggesting tens of billions of trees planted as part of these broader anti-desertification initiatives over recent decades. It's within this broader context that Przewalski's horse reintroduction has drawn some genuinely interesting scientific attention regarding the potential ecological role these large grazing animals might play within these recovering desert and steppe ecosystems, considerably beyond simply representing a successful species conservation story in its own right. It's genuinely important to be honest and careful here about exactly what current science can and cannot confirm regarding this specific ecological question, because some of the more widely circulated coverage of this story has made claims about dramatic desert transformation that go considerably further than verified, peer-reviewed ecological research currently supports. It would be inaccurate to claim that Przewalski's horses alone have single-handedly reversed desertification across northwestern China, or that their reintroduction represents some kind of complete substitute for the broader combination of tree planting, grazing management, and climate adaptation efforts already underway across this region. That kind of sweeping claim overstates what's actually been scientifically established. What genuine ecological research does support, and what's worth understanding in proper context, is a considerably narrower, but still genuinely significant, body of scientific understanding regarding the ecological role large grazing herbivores generally play within grassland and steppe ecosystems more broadly. Grazing animals like Przewalski's horses interact with their surrounding landscape in several specific, well-documented ways. Their grazing activity helps prevent any single plant species from becoming dominant, encouraging greater overall plant diversity across grassland habitat. Their movement across the landscape, along with their digestive processes, helps disperse plant seeds across considerable distances, potentially helping vegetation recolonize areas it might not otherwise easily reach on its own. Their hooves, moving across compacted or crusted desert and steppe soil, can help break up that surface layer, potentially improving water infiltration and creating more favorable conditions for plant germination in certain soil types. And their waste contributes organic matter and nutrients back into soil that, in heavily degraded desert regions, often suffers from depleted nutrient content. These general ecological principles, well established within the broader field of grassland and rangeland ecology, provide a genuinely reasonable scientific basis for believing that reintroduced grazing herbivores like Przewalski's horses could contribute positively to ecosystem recovery within the specific reserves and habitat areas where they've been reestablished. This is meaningfully different, though, from claiming that scientists have definitively proven, through rigorous, published, peer-reviewed research specific to these particular Chinese reintroduction sites, that Przewalski's horses have single-handedly transformed previously barren desert into thriving grassland in a manner separate from and superior to the broader combination of conservation and land management efforts already underway across the region. The honest, accurate framing here is that these horses represent a genuinely successful species conservation story, reintroduced into a landscape that China's government and conservation scientists are simultaneously working to rehabilitate through multiple different complementary approaches, with these horses likely playing some genuinely positive ecological role within that broader recovery effort, rather than representing a single, standalone miracle solution to desertification on their own. This distinction matters, and it's worth taking a moment to explain why getting this specific nuance right actually makes for a more genuinely interesting, more scientifically honest story than the more dramatic, oversimplified version that sometimes circulates online. Ecosystem recovery in genuinely degraded arid and semi-arid landscapes is rarely, if ever, the product of a single intervention or a single species acting in isolation. It's typically the product of multiple different factors working together over an extended period. Changes in land management practices, active revegetation efforts, shifts in precipitation and climate patterns, and, in cases like this one, the reintroduction of species that had previously played some meaningful ecological role within that landscape before human activity disrupted it. Przewalski's horses, having evolved specifically within Central Asian steppe and desert ecosystems over an extended evolutionary timeline, likely did play some genuine functional ecological role within these landscapes historically, and their return to at least some portion of their former range represents a genuinely interesting opportunity for ongoing scientific research into exactly how, and how significantly, their grazing and movement patterns interact with and potentially support broader habitat recovery efforts already underway across this same general region. Beyond the specific ecological questions, there's a genuinely compelling, broader story here about what successful, patient, multi-decade conservation work actually looks like in practice, considerably different from how conservation success stories are often portrayed in shorter, more compressed media coverage. This wasn't a story that unfolded over a single dramatic season, or even a single dramatic decade. It took 40 years, spanning multiple generations of both the horses themselves and the human researchers, veterinarians, and conservation officials who managed this effort continuously across that entire period. Careful genetic management using increasingly sophisticated DNA testing technology that didn't even exist when the project first began in 1985. Staged behavioral rehabilitation through semi-wild enclosures specifically designed to prepare captive-raised horses for genuinely wild conditions, and gradual, deliberately paced expansion across multiple distinct release sites and provinces, rather than a single, rushed, all-at-once reintroduction effort that would have carried considerably higher risk of failure. It's worth understanding a bit more about the practical, day-to-day work involved in monitoring a reintroduction effort of this scale and duration, because it illustrates just how much sustained scientific attention a project like this genuinely requires to succeed over the long term. Individual horses within these reintroduction programs have been tracked using specific identification codes, allowing researchers to monitor each animal's health, movement patterns, and reproductive success across years and even decades of ongoing observation. This kind of granular, individual-level monitoring allows conservation scientists to identify problems early, whether that's a genetic issue emerging within a particular breeding line, a health concern affecting a specific herd, or a habitat-related challenge affecting horses in one particular release location differently than another, and to adjust management strategies accordingly, rather than simply releasing animals into the wild and hoping for the best without any ongoing scientific oversight. The sustained, decades-long commitment to careful monitoring and management is precisely what has allowed the population to grow as steadily and as successfully as it has from that initial handful of founding animals to the current population exceeding 900 individuals living across 4 provinces. It's also worth noting that this success didn't happen without setbacks along the way. Species reintroduction efforts of this scale and duration virtually never proceed in a perfectly smooth, uninterrupted upward trajectory. Individual populations at specific release sites have, at various points throughout this 40-year effort, faced genuine challenges, including disease concerns, harsh winter conditions that tested the horse's rewilding preparation, and the ongoing careful genetic management required to prevent the kind of inbreeding depression that could have undermined the population's long-term health at any point along the way. The fact that the overall project has continued expanding and strengthening despite these individual challenges reflects the genuine value of the patient, adaptive management approach Chinese conservation scientists have maintained throughout this entire multi-decade effort. There's something genuinely worth reflecting on in the broader arc of this specific story, beyond simply the technical conservation achievement it represents. In the 1970s, Przewalski's horse existed only behind fences, in a scattering of zoos across countries thousands of miles from the Central Asian steppes and deserts where the species had evolved over tens of thousands of years. The entire future of this species rested on a small handful of captive animals, their genetic diversity already narrowed by the circumstances of their survival, with no guarantee whatsoever that any meaningful effort to return them to genuinely wild conditions would actually succeed. Reintroduction efforts for other species, attempted under broadly similar circumstances in various parts of the world, have not always achieved comparable success, making the sustained, expanding recovery of Przewalski's horse in China a genuinely notable outcome within the broader history of conservation biology. Today, the sound of hooves once again echoes across stretches of Xinjiang, Gansu, Inner Mongolia, and Ningxia that had gone silent in terms of this particular species for decades. More than 900 Przewalski's horses now live and roam freely across this landscape. Descendants of that original handful of animals brought back from foreign zoos in the mid-1980s, animals that have, over 4 decades and multiple generations, gradually relearned, or learned for the first time, exactly how to survive as genuinely wild horses in some of the most challenging desert and steppe terrain found anywhere on the planet. What makes this story worth understanding in its full, honest complexity, rather than simply as a dramatic, oversimplified tale of horses single-handedly transforming a barren desert, is what it actually represents: a genuinely successful, carefully managed, scientifically rigorous, 4-decade conservation effort, unfolding within a broader landscape that China's government and conservation scientists are simultaneously working to rehabilitate through multiple complementary approaches, including large-scale tree planting, grazing management, and ongoing ecological research into exactly how these reintroduced horses interact with and potentially support the broader recovery of the ecosystems they now call home. The horses themselves didn't arrive as some kind of singular ecological miracle cure. They arrived as the last representatives of an entire species, given, through decades of patient, careful human effort, a second chance to do what their ancestors had always done, roam freely across the open steppe and desert, exactly as they had for tens of thousands of years before human activity nearly erased them from existence entirely. That, on its own terms, without any need for exaggeration or embellishment, represents a genuinely remarkable achievement